The James Webb Space Telescope has proved to be a groundbreaking invention for scientists and the world. From showing Jupiter like never before to revealing previously unseen gas and dust in spectacular spiral galaxies, the James Webb Space Telescope keeps increasing our knowledge of the cosmos. One of its groundbreaking discoveries that have left scientists on their toes is the discovery of the sign of life on one of the exoplanets. What is this sign of life? And which exoplanet portrays this sign? This is what we're going to look at in today's video. Stay until the end to find out the discovery's influence on deep space exploration. While space exploration has proved expensive and complicated, scientists' curiosity has been the steering wheel that keeps pushing them into searching for answers to their questions about space. This thirst for answers has led to the invention of various telescopes, and the most recent one, the James Webb Space Telescope, has proved to be the most powerful space telescope to date. The James Webb Space Telescope invention wasn't child play, as it took decades to design and $10 billion to bring into reality, not to mention the efforts of the scientists. Luckily, the JWST has justified all these expenditures, and it has been a good provider of answers to all the questions astronomers have faced in their space exploration. Launched last year on Christmas Day, of all the 444 listed details of things that could go wrong with the telescope and destroy the mission, none has happened, which was a huge relief to NASA. The James Webb Telescope was inserted into space at Corot, French Guiana, aboard San Arian Space Ariane 5 rocket, and it took just a month for it to travel nearly 1 million miles, 1.5 million kilometers, to its permanent home, which is the Lagrange Point 2. Not only is the invention process of the JWST complex, but its structure is also. It has an origami-like structure, and throughout its ascent to its permanent place, the 18 honeycomb mirrors were to unfold and form a big mirror with a final size of 6.5 meters. Each of the 18 hexagonal mirror pieces of the upper part had to align within 15,000 widths of a man's hair. Even the operating temperature can be a problem for the JWST, as it requires extremely unimaginable temperatures. The JWST needs to be kept cold to work correctly, i.e., detect infrared lights. Exposure to improper temperature will cause infrared noise in the background, distorting the telescope's output. The mid-infrared instrument on the JWST had to be cooled with the world's coolest element, gaseous helium cryocooler, to under 7 kelvins to achieve this extraordinary cooling requirement, minus 447 degrees Fahrenheit, or minus 266 degrees Celsius. When the JWST works, the detectors and electronics generate heat balanced by the cryocooler to keep the MIRI at a stable and very cold temperature. With the launch and configuration now gone smoothly, the Space Telescope will support about 300 observation programs in its lifetime. Part of the work outlined for the $10 billion James Webb Telescope is to look far out into the cosmos and deep into the past to picture the very first star and galaxies, to uncover the history of the Big Bang. Among the high-priority tasks is to help in the understanding of dark matter and dark energy. These two terms are among the most mysterious objects in the universe. Another important thing that the JWST will help scientists with is the study of the formation of exoplanets. All of the planets in our solar system orbit around the sun, but other planets orbit around other stars. These are exoplanets. The problem with an exoplanet is that they are very difficult to view with telescopes, as they are hidden by the bright glare of the stars they orbit. So astronomers devise another way to detect and study these slightly invisible planets. The devised way is by studying the effects these planets have on the stars they orbit. However, before the invention of the JWST, scientists used different indirect methods to detect these planets. One such is the wobble method. This method entails looking for a star that is wobbling. A star that doesn't orbit perfectly around its center means that it has planets orbiting it. Scientists have used this method to find hundreds of exoplanets. However, Only big planets, Jupiter as an example, or even bigger than Jupiter, can be seen this way. Smaller planets like Earth are hard to see because their wobbling is like their size, making it difficult for scientists to detect. NASA even launched a spacecraft called Kepler in this venture of detecting exoplanets. Kepler used a method called the transit method to search for exoplanets. This transit method occurs when a planet passes in front of its star. As the planet passes before the star, it reduces its light. This process means if a planet passes in front of the star, its brightness will reduce. Astronomers can figure out the size of the planets based on how much the star's brightness lowered, and they can also work out how far away an exoplanet is from its star. During transit, the planet's temperature can also be detected. As it transits, some light will pass through its atmosphere, which can be examined to determine what different atmospheric elements influenced its particular dispersion. The atmospheric composition is important to determine the habitability of the planet. These help determine the planet's temperature, letting us know if the planet's surface is habitable or inhospitable to life. The Kepler mission was successful, as thousands of exoplanets have been discovered. Now, with the JWST, signs of life are being discovered on these exoplanets. PROXIMA b is one of them. This exoplanet was discovered in 2016 by some researchers at Queen's Mary University, led by Dr. Gilliam Anglada Escude. It orbits Proxima Centauri and is 4.2 light-years away. Researchers thought it to be a rocky terrestrial planet, slightly larger than the Earth, and they predict it could contain liquid water. With the James Webb Telescope's infrared light, scientists predict it can be configured to spot evidence of LED light on the Proxima b. Since it orbits very close to its small red dwarf star, it's likely to be tidally locked with a permanent night side. So, Harvard astronomer Avi Loeb, part of the study team, hypothesized that civilizations might use powerful mirrors or require extremely bright LED-style light to illuminate their cities. They suggest that by using their near-infrared instrument on the James Webb Space Telescope and looking for the sign of LED light waves in the light from the planet and its host star, they'll be able to detect artificial light if it exists. Another exoplanet that the scientists detected a sign of life on was the WASP 39b, a hot gas giant orbiting a sun-like star about 700 light-years from Earth. The sign of life found on this exoplanet is carbon dioxide, an important component of Earth's atmosphere. It was discovered using JWST's near-infrared imager and slitless spectrograph (NIISS) instrument. WASP 39b is a huge exoplanet. Its mass is similar to Saturn's, and its diameter is 1.3 times greater than Jupiter's. It has an average temperature of roughly 900 degrees Celsius because of its close orbit to its star. The high temperature increases the atmosphere, making it easier for JWST to see starlight shining through it. When light from a star is reflected through a planet's atmosphere, molecules in the atmosphere absorb some of the light in its unique wavelength ranges. With carbon dioxide absorption of infrared lights, previous telescopes didn't observe in the right range or with the appropriate method to detect its signature. But since JWST observes in the infrared, it picks it up immediately. Natalie Batalla observed the data thoroughly at the University of California, Santa Cruz, with a team of more than 100 researchers to ensure its validity. Despite running them through 4 separate algorithms, the results were the same. All 4 showed clear signs of carbon dioxide. The carbon dioxide signature was just screaming at us. Processing the data was not hard. It was easy, straightforward, and honestly beautiful, says Batalla. The result has a statistical significance of 26 sigmas, meaning that the probability of discovering such a signal is less than 1 in 10,149. According to Eliza Kempton from the University of Maryland, part of the research team, it's exquisite. Finding this kind of sigma is rare. The researchers discovered that WASP 39b had more carbon and oxygen than its host star, indicating that its formation didn't occur when the gas around the star collapsed all at once. Rather, its rocky core formed first and subsequently accreted the gas that makes up its atmosphere. These findings are similar to how we think the planets in our solar system evolved, and more research into the exoplanet's atmosphere may reveal more. The fact that scientists could detect carbon dioxide in this giant's atmosphere will help us understand the atmosphere of rocky worlds similar to Earth, which is one of the goals of JWST. It might also be helpful in the search for alien life. When combined with other molecules like methane, it may be an interesting biosignature, says Jesse Christensen at the NASA Exoplanet Science Institute in California. Stay tuned to this channel for more news on the most powerful telescope ever built and the spectacular discoveries to come. Thanks for watching this video. See you in the next one. Till then, bye.